In this video, we'll learn the second point. The most common use of this keyword is to eliminate the confusion between instance variables and local variables with the same name. So let us understand this point by writing a program. In this program, we demonstrate how this keyword distinguishes between instance variables and local variables. Here I have defined the class named employee, instance variable EID of type int, and instance variable name of type string. There is a default constructor with no code inside it. There is a parameterized constructor and there is a toString method. We are not using default constructor anywhere in our program. We are using parameterized constructor. But as a good programmer, it is always a good practice to write default constructor. It doesn't matter if you don't write any code. You may keep it empty. Why should you always include default constructor? If somebody is using your class and if that guy creates an object with no arguments, it will give a call to default constructor. And if default constructor is not present in your class, he will get an error. And compiler includes code for default constructor only when you don't write any constructor. In case if you are writing parameterized constructor, compiler doesn't write code for default constructor on your behalf. So to avoid such errors, always include default constructor. There is a class thisDemo that contains main method. Execution starts from here. We are creating an object named E and passing two arguments. First is of type integer and the second argument is of type string. So when your object is created, memory for object is allocated. Reference variable E will be created on the stack and actual object will be created on the heap. After creation of an object, call to the constructor will be given implicitly. Now the interpreter will search for the matching constructor having data types int, string in class employee. So from here, the control of the program will go to the parameterized constructor having arguments int, string. The first argument 1 is stored in the first parameter, that is EID equal to 1, and the second argument Mira is stored inside second parameter, that is name equal to Mira. Now these parameters EID and name are local to this constructor. Hence, memory allocation will happen on the stack. Local variables are stored on the stack. Hence, inside the stack, memory for local variable EID and memory for local variable name will be reserved belonging to the constructor having parameters int, string. And the values passed from the object will be stored inside these local variables on the stack. Now once memory allocation happens to these local variables, the control will come inside the constructor and code inside the constructor will execute. Have a look at the code. We are writing EID equal to EID. So how do I assign values of local variables to the instance variables? We write instance variable equal to local variable. But in this case, the names of instance variables and local variables are same. Names of the instance variables are EID, name, and names of the local variables are also EID and name. So over here, this EID to the left is the instance variable EID. And this EID to the right is the local variable EID. I am assigning instance variable EID is equal to local variable EID and instance variable name is equal to local variable name. But as the instance variable names and local variable names are same, interpreter gets confused. Interpreter doesn't understand which is instance variable and which is local variable. Hence, because of the confusion, the values of the local variables are not assigned to the instance variables. Because the interpreter doesn't understand that variable to the left is an instance variable, it doesn't assign any value to it. And what are the default values of instance variables? By default, when there is no value assigned to the instance variable of type integer, the default value is 0. And when there is no value assigned to instance variable of type string, the default value is null. So after execution of this code, control goes back, but no values are assigned to the instance variables. Hence, inside the memory, EID is having value 0 which is its default value, and name is having value null, which is its default value. The values which we are passing through the object are not getting assigned to the instance variable because of the confusion between same names. Now the next statement is SOP, and you try to print object E. When you print the object, an implicit call to toString method is given. So control comes over here. Code inside toString method executes. We are returning the string employee ID equal to the value of EID is retrieved, that is value 0. \n is for the new line. A new line will be added to your output. Then the string employee name is written back, and instance variable name will retrieve value from its object, that is null. Control goes back. So the data we get is EID equal to 0 and name equal to null, and it is printed to the output screen. Now after execution of this code, the memory allocated for the local variables of this constructor is released as soon as the control comes out of this constructor. So your output will look like this. Employee ID is equal to 0 and employee name is equal to null. The actual values sent through the objects are not assigned to the instance variables because of the confusion between the same names. Now how do you tell the interpreter that left side variables are instance variables and right side variables are local variables? Here comes the use of this keyword. By using this keyword, you can distinguish between instance variables and local variables. So wherever your instance variables are, you will write this .eid and this .name. You need to include this dot in your code, and now the interpreter will understand that the EID which is invoked on the current object this is an instance variable EID, and EID which is not invoked with the current object this is local variable EID. The variable name which is invoked on current object this is instance variable, and variable name to the right is local variable. So now when you create an object, memory allocation happens. Your reference variable is created on the stack, an object is created on the heap. As soon as the object is created, call to the parameterized constructor is given, and these values 1 and Mira are sent to the parameterized constructor. Over here, values are stored inside local variables, EID equal to 1 and name equal to Mira. Memory allocation for local variables happens inside the stack. So this is the local variable EID and name belonging to the constructor having parameters int, string. When the control comes inside, interpreter reads this .eid and it understands that EID to the left is an instance variable and EID to the right is a local variable. Now it is able to assign the value. So what is the value of EID? That is 1. Hence, instance variable EID inside object E will have value 1. This .name is the instance variable. What is the value for name? Mira will be assigned to this instance variable. Hence, inside the memory, instance variable name will have value Mira. And now the object is actually initialized. So after this block of code is executed, memory allocated for its local variables is released from the stack. So here the memory is freed. Control goes back, call to the toString method is given, and the object data is printed. Now your output looks like this. Employee ID equal to 1 and employee name equal to Mira. So this keyword helps to distinguish the difference between instance variables and local variables.